So we're going to talk about parent function. Specifically, we're going to talk about absolute value. This is going to be a quadratic. Cubic, this is a square root, and this is linear. And we're going to talk about how we can use these ordered pairs in order to quickly graph translated functions. So I want you only watching if you're with me in class or you're watching this video. Each of these is an example of an absolute value function. Now, how can I use this data? So this is going to be numbers that come from the ordered pairs from an absolute value. So the first thing I'm going to do is I've already created a graph that we can use, and then I'm going to go off to the side and I'm going to write this down. So this is going to be absolute value. You're just paying attention, you're not taking notes. So y equals the absolute value of x. So the absolute value of -2, the output is 2. The absolute value of -1, 0, 0, 1, 1, and 2, 2. A common mistake I see students make, will you shut the lights for me? A common mistake I see students make is that they think we just change the sign. So yes, the absolute value of -2 turns to +2, but the absolute value of 1 and 2 doesn't turn to negative. Remember, absolute value means how far something is from the origin. So how can I use this data to quickly graph these three? Well, this is what we went over in a short video that you watched, and so I'm going to start by graphing just the first parent function. Notice there's no number behind it or in back, so there's going to be no shift to the left or right and no shift up and down. So I literally would go to 0, 0, and then I'd go over 1, up 1, over 2, up 2, left 1, up 1, and left 2, up 2. This is directions. From the origin, I would go left 2, up 2, left 1, up 1. Here, this should have been 0, 0. Then right 1, up 1, and right 2. And so it's looking like this. And you saw that in yesterday's video. That is a review for you from 8th and 9th grade. Now, let's talk about translated functions. So inside is going to represent the horizontal shift, and it lies to us. So instead of going to the right, we're going to go left because it lies to us. And then in back tells us the truth. It's the vertical shift. So I'm going to go left 2 and down 3. So on my graph, I'm going to go left 2 and down 3, and then I'm going to make a little mark there. That's what I refer to as this is going to be the end point of my V shape. So think of this as this point right here. So this is now 0, 0. From this point, I'm going to go to the right 1 and up 1, right 1, up 1, right 2 from this point and up 2, right 2 and up 2, and now to the left, left 1, up 1, and left 2, up 2, and we're making the same shape. We are going to learn something new out of these 5 examples. All right, now why did this confuse students? And it confused students because they're so used to having the absolute value on the left and a vertical shift on the right. This one is not set up like that, but you could rewrite it if you wanted to. So if you wanted to, you could rewrite it with a +2 in front of the absolute value and a -4 in back. So when you don't see a value inside, it means we're not going to shift to the left or right. In this case, we're only going to shift down 4. So on the same graph, I'm going to shift down 4. 1, 2, 3, 4. Now this is something new that was not on your video yesterday. What is different about the first 2 examples and the third example is now I have a value that's directly in front of the parent function. And what changes is the shape then. We're still going to have this V shape, but based on whether that number is greater than 1 or between 0 and 1 will make a difference whether this V shape rises at a really fast rate, so the V is going to become skinnier, or the V is going to become wider. Now, how can we accurately graph it? I'm going to take whatever this value is, now listen closely, whatever is directly in front of the parent function, and we're always going to multiply it by the y's. So I'm going to write this ordered pair. This was -2, -1, 0, 1, and 2. I got those from the x values. Now, the y, I'm not going to write down 2. I'm going to take whatever is directly in front, which in this case is a 2. 2 times 2 is 4. 2 times 1 is 2. 2 times 0 is 0. 2 times 1 is 2. And 2 times 2 is 4. Each one of the y's, always the y's, whatever's directly in front is going to impact the y's. Now this is where I have the starting point because I've gone, I can't go left or right, I'm dropping down 4. If this confuses you, I suggest to students that after you use it, you go back and you cross it out. So from this point, this is like my 0, 0. I'm going to go right 1 and up 2, right 1, up 2. Then I'm going to go back to the starting point, right 2, up 4, right 2, up 4. Now to the left, left 1 and up 2. And left 2 up 4. Remember, you're not going to be able to use a calculator What you will have is you are going to be provided the opportunity to write these down the day before the test. And then I'll give you this half piece of paper, and you will have these ordered pairs to use for support as you graph by hand. Let's keep going. So I've done example 1, 2, and 3, and now we're going to look at the last 2 examples from this set. So on here, I'm going to shift not to the left, but it lies to me, to the right 3 and down 4. Right 3 and down 4. I'm going to start by doing that. And this is getting a little complicated, so let me make a new graph so it looks a little better here. Once again, right 3, down 4. 1, 2, 3, and down 4. 1, 2, 3, 4. This is going to be like my starting place. And I'm going to come off to the side here so that we can see this, and I'm just going to write down what were those ordered pairs of the parent function once again. Okay, what do I do next? Well, I translate it again to the right and down, and now anything that's directly in front of the parent function will be multiplied always by the y. So what's half? What's half of 2? Well, half of 2 is 1. What's half of 1? 1 half. Half of 0 is simply 0 because you're taking 2 times 1 half. 2 times 1, 2 times 0. I may have said that wrong, sorry. 2 times 1 half, 1 times 1 half, 0 times 1 half, 1 times 1 half, and 2 times 1 half. Again, I'm taking this value right here times each of the output values. Now, this is my new ordered pair. It is negative 2, 1. It is negative 1 and 1 half, or you could write it as 0.5, 0, 0, 1 and 1 half, and 2 and 1. These are the ordered pairs. So from here, this is my 0, 0. I'm going to go right 1 and up a half, right 1 and up a half, right 2 and up 1, left 1 and up a half, left 2 and up 1. And we can see this time, compared to our previous ones, that this V-shape has now been flattened out. Why is that? Because this value is between 0 and 1. Anything between 0 and 1 out front is going to flatten out the shape. Okay, I'm going to change this up. This very last one is a brand new concept that you may have learned in Algebra 3-4, or maybe your teacher didn't go over it. So let me go over this one with you right now. Okay, what is different about this? There's 4 things that are different. We now have a negative sign in front of the x, and whenever that happens, we need to factor out that negative sign. It's acting like a negative 1. So I factor out the negative 1, and I ask myself, negative 1 times what gives me a negative x? That'd be an x, because negative 1 times x is negative x. And negative 1 times negative 1 is a positive 1. So I'm just distributing to make sure that when I distribute the negative sign, I'd come up with exactly what was up above. All right, I'm going to go ahead and write this down right now once again because I know this problem will be more complicated for most students. It may be the first time you have seen this. Okay, you ready? When I look at this, I'm looking at this portion right here. Turn to your partner. Does this portion right here, not up above, does this say move to the left, right, up, or down? It lies to us, so instead of moving to the left, we're going to move right 1. This tells us the truth, so we're going to move up 4. That's the first thing I'm going to do. Right 1, up 4. So I have my graph. I'm going to use this bottom one. Right 1, up 4. I'm going to make my little line. That's my starting. And by the way, I've used that portion, so I'm going to cross it out. There's no confusion. As I spoke about in examples 3 and examples 4, if there's any value directly out front, we're always going to multiply that value by the y's. So negative 2 is going to be multiplied by the y's. Negative 2 times 2 is negative 4. Negative 2, 0, negative 2, and negative 4. I've taken care of that. What's new right now is we have a negative sign in front of the x. And again, you always have to factor that out if it's in front of the x. What does this impact? It impacts the x's. So I'm going to take this negative 1 times the x's. Negative 1 times negative 2 is 2. 1, 0, negative 1, and negative 2. So this is my new ordered pair. 2, negative 4, 1, negative 2, 0, 0, negative 1, negative 2, and negative 2, negative 4. How do I use those 5 ordered pairs to graph this? Well, this is my 0, 0. I'm going to go left 1 and down 2. Left 1, down 2. Left 2, down 4. Left 2, down 4. Right 1, down 2. And right 2, down 4. And right 2, down 4.